Good morning, class. Today we're going to talk about the law of conservation of momentum and how it relates to collisions. The law of conservation of momentum is as follows. The total momentum in a closed system will not change. However, the individual momenta from objects in the system can be transferred between objects within the system. This means that momentum from one object can be transferred into another object in the system, but the grand total of all of the momentum in the system will never change. One of the keys here is that we are talking about a closed system. And a reminder that a closed system is a situation that you view that has no outside influences. One of the most common forms of outside influences that we are going to be dealing with is friction. Friction is always going to be part of an outside system. Now, if you're wondering how would you find the momentum of a system, well, to calculate that, you simply add the momentum of each object in the system. So let's do a little example just to help us determine the momentum of a system. We have a 32 kilogram cart heading west and a 66 kilogram cart heading east. Let's take a moment to draw out our situation so we can visualize this and help ourselves out. So we have our two carts moving here. I'm going to call my 32 kilogram cart A, and I'm going to call my 66 kilogram cart B. Now we notice that they're heading in different directions, and momentum is a vector. So we're going to have to define one direction as positive and the other direction as negative. Most of the time people state that east would be the positive direction and west would be the negative direction, meaning this would be positive 2 meters per second, and the 32 kilogram cart is moving at negative 5 meters per second. Now, how do I find the total momentum? For this, I would just take the momentum of object A and add the momentum of object B. And the momentum of object A should be pretty easy. It'd be the mass of object A multiplied by the velocity of object A, or 32 multiplied by negative 5. 32 times negative 5 is negative 160. And this is kilogram meters per second. What about cart B? Well, the momentum of B would just be the mass of object B multiplied by the velocity of B, or 66 kilograms times 2 meters per second. That's going to be 132 kilogram meters per second. So to find our total momentum, we just have to add these two values, negative 160 plus 132. Or we see that it is negative 28 kilogram meters per second. And remember here that our negative means to the west. So hopefully you find that finding the total momentum of a system is actually rather simple. You just take the momentum of each piece, and the tricky part here is you have to pay attention to their directions. If you don't pay attention to the directions, you'll end up missing minus signs, and that's going to cause you problems. So the law that says the conservation of momentum means that the total amount of momentum in a closed system does not change, even after an event or a collision. To summarize what this would mean for us in our calculations, it means that our total initial momentum has to be equal to our total final momentum. Or, as a formula, total initial momentum equals total final momentum. And this formula is going to help us for any situation that is a collision or explosion. That's what the law of conservation of momentum is really good for. It's good for looking at multiple objects in collisions and explosions. So if you see the word collision on a worksheet, that is a hint to tell you to look at the law of conservation of momentum, or to use this formula. So let's do this example, which uses the same initial situation and see what happens. The same cars from our previous example collide, and after the collision, the 32 kilogram mass rebounds and is traveling east. Determine the final velocity of the 66 kilogram mass. Whenever we have a collision, since we're using the law of conservation of momentum, we need to consider the initial and the final situation. So, split your problem in two and draw it out. And we know our law here says that my total initial momentum is going to equal my total final momentum. Now, we already did the work to find our total momentum. I'm going to just say see work above because it's already done for us. This is negative 28. Now that's going to equal our total final momentum. We need to look at our final situation and see what's happening. Let's observe. We would still have two carts, the 66 kilogram cart and the 32 kilogram cart. And they would still have the same names because they're the same carts. Here's cart A, and here's cart B, but they have new velocities. Cart A is now traveling 1 meter per second to the east. And cart B, we don't know its velocity, and that's what we're trying to find out. So the final momentum is going to be the momentum of cart A in the final situation added to the momentum of cart B in the final situation. Or we can break this down. The momentum of A is the mass of object A multiplied by the final velocity of A. And the momentum of B would be the mass of B multiplied by the final velocity of B. Well, let's plug in the things that we know. We know the mass of A is 32, and we know the velocity of A is 1. We know the mass of B is 66, and the velocity of B we don't know. But what we do know is that all of this is equal to the negative 28 kilogram meters per second from the initial momentum. And we have to make sure that we are careful to keep the same directions as we had before. So you notice that I actually had this 1 meter per second is positive because we said positive was east. Well, this is actually some pretty easy math because we will be left with negative 28 equals 32 plus 66 velocity final B. And we can go ahead, subtract 32 from both sides, and that would get us negative 60 equals 66 velocity final B. And to get velocity final B on its own, since it's multiplying, that's why we divide both sides by 66, and we get negative 60 over 66, or velocity final B is equal to 0.91 in the negative direction meters per second. And remember, what does this negative mean? This negative means to the west. So we can see after this collision is the 32 kilogram mass rebounds and heads to the east, and the 66 kilogram mass rebounds and heads to the west. Let's wrap this up with the discussion of the two types of collisions that we will find. The two primary types of collisions that we're going to be talking about are elastic collisions and inelastic collisions. Elastic collisions, you might understand naturally. Elastic collisions are considered bouncy collisions. With our bouncy collisions, both masses will have different velocities before and after the collision. There's also something called perfectly elastic collisions, and they conserve kinetic energy. But this is something that we might actually talk about in Physics 12 because we don't really have the time for that right now. For inelastic collisions, these are often considered sticky collisions. And this is what happens when two things collide and then are stuck together. In this case, we would go ahead and notice that both masses have the same final velocity because they are now stuck together. In the upcoming week, we're going to talk about both elastic and inelastic collisions and the reverse type of interaction, which is the explosion. We're going to use these and the law of conservation of momentum to help us understand how we can get values of multiple objects when they are interacting. That's it for today. Have a good day.